Okay, the purpose of this video is to introduce you to an analysis of variance, also called the F-test, and it's calculated a little differently than the other tests that we've done thus far, which would have just a formula. It's actually done in steps rather than just having one particular formula. You sort of have several quantities that you have to calculate. Now, just to refresh your memory, what we're dealing with here is we're going to start with the simplest case where you only have one IV, but you have more than two groups. And we're going to calculate the scenario where we have between subjects, different groups of subjects. That, of course, would be a completely randomized design, and you're going to do what's called a one-way analysis of variance, an F-test. And that differs from, say, like a factorial ANOVA because there's only one independent variable. It's the simplest case. This is the only case we're going to do by hand. The others, we'll do a repeated measures, factorial, repeated measures, factorial, and mixed factorial, but we'll only do those in SPSS. I'll show you how to do those in SPSS in subsequent videos. But we're going to do this so that we get a sense of how this formula works and how we go about calculating the variance, because the ANOVA stands for analysis of variance. So what we're going to do is calculate the total variance and then begin to break that up, partition that up into pieces. And this is things that we'll talk about a lot in class to reinforce what we're learning here. So that's a little bit of the background. So when we're calculating an F-test for, say, like one IV, we say like the simplest case if we have three groups. And we're going to do an example in the next video with numbers to plug these numbers in, but I just want to give you a sense of the different things you'll have to quantify and what they stand for. So the first thing is we're going to calculate the total variability in our data set. And this is something called the total sum of squares. So this is the total sum of squares refers to all of the variability in our data set. Now it's abbreviated SST, which stands for sum of squares, and then of course the subscript T means total sum of squares. And we're going to get this up by taking each score, which is represented by X, is each individual score, and we're going to see how that varies from this quantity, which is X bar with a subscript T, which stands for the grand mean. So that's what that means, grand mean. And the grand mean is just a term to represent the mean of all of our data. So the way you would get this is if you have three groups of data, you would add up all the scores across all three of your groups, divide by the total N, total number of scores. That's going to give you the grand mean. And what we'll do is we'll take each score, subtract it from the grand mean to get the variation there, how each score varies from the grand mean. We square it, of course, to get rid of any negative signs. So that's why we square it, right? We're going to square it to get rid of the negative signs to get the variability, just like when we calculated variance very early in this semester. And then we sum it all up. That's what we do. That's how we get that thing. So it's tedious, yes. Difficult in concept, hopefully not. So that's the total sum of squares. Then what we're going to do, and by the way, the total sum of squares can be broken up into two pieces in this particular design. More pieces for more complex design. Sum of squares between groups. So that variability which is due or happens between groups due to, we hope, the independent variable. So this is the variability between groups. So it's abbreviated sum of squares sub B for sum of squares between groups. And what we're going to do is we're going to take it's variability. So we take two numbers and subtract them, right? In this case, we're going to subtract this mean, right, which represents the group mean for any particular individual group. And that any particular individual group there has a subscript of J. So J represents your group. So if you had three groups, J could equal a value of 1, 2, or 3 representing first, second, or third group. If you had 10 groups, J could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So this means you take each individual group mean and you subtract it from the grand mean. So now we're focusing on how each individual group mean varies from the grand mean. We square it to get the variance, right? And then we're going to weight it by the size of that group. So if the groups have the same number of people in it, they'll all have the same weight. But if they varied, if they didn't have the same number of people, which would hurt your power, by the way, you want to have the same number of observations in each group. But if they did, then they're going to be weighted the same. If not, they would be weighted a little differently depending on the size of the group. So we're going to weight that product, I guess, or difference that's squared. And then we're going to sum them up. So if we had 3 groups, we're actually going to have 3 of these terms, 1 for each of the groups. That's our sum of squares between groups. Then our sum of squares within groups, abbreviated SSW. This is the variability within each individual group. And we're going to get this, and again, if we have 3 groups, we're going to have 3 major terms. If we have 10 groups, we're going to have 10 terms. And so what we do is we take each individual score in that particular group. So it has a subscript of 1 representing the first group, and we subtract that score from its group mean, right? So the first score in the first group subtracted from its group mean. We're going to square it. We're going to sum those up. So we do that for the first score, second score, so on, how many ever scores we have in that first group. We're then going to do the same thing for the scores in the second group, okay? So if we had 4 or 5 scores in the second group, we would have 4 or 5 scores subtracted from their group mean, squared, and then summed up. And we do this for every group that we have, which is why you have ... out to k, because k represents the number of groups. So if we had 3 groups, k would equal 3. If we had 10 groups, k would equal 10. K represents the number of groups. Okay? So those are the basic quantities. We're going to continue to work with them here in just a second, but we also need degrees of freedom. When we have 3 different kinds of degrees of freedom in a design like this, we have degrees of freedom with a subscript t, which you might guess means total sum of squares. And we get that by taking the total number of scores, so all of the observations that we have across all of our groups, and we just subtract 1, you're going to have the total number of scores. We have a degrees of freedom for between groups. So this is the variability, which is due to our independent variable. So it's the number of groups, which is k, minus 1. So if we had 3 groups, right, it would be 3 minus 1, or 2 degrees of freedom, okay? And you can think of this as the degrees of freedom go into, it's whatever the scores that go into our sum of squares, right? So for the degrees of freedom in total, all of the scores went into this value, right? You took each score and you subtracted it from the gradient mean. So that's the degrees of freedom are n minus 1. Here we had how many ever terms we had dependent on the number of groups we had. So it's number of groups minus 1. So as you might gather, the within groups, it's the number of scores within each group, and it's really the degrees of freedom for that first group plus degrees of freedom for that second group plus degrees of freedom for that third group. So what you get is you get little n minus 1, and you would add them all up. If they had different n sizes, you would add them all up. But assuming they have the same n size, you can multiply by a factor of k, because it would be the same across the number of groups and get your degrees of freedom, right? So those are the 3 different kinds of degrees of freedom. So once we have these quantities and our degrees of freedom, now we can form what's known as a mean square. So it's an average variability, right? This is just like a raw sum of squares, raw variability, variance, if you will, in our group. We want an average. So what we get for the average is we take our sum of squares between groups, whatever that value is, and we divide it by the degrees of freedom between groups, okay? And we'll have our mean square between groups. We do the same thing for the mean square within groups. We're going to take sum of squares within groups, divide by the degrees of freedom within groups to get that quantity. Now our F ratio, at the very end of all of this, the F ratio is the mean square between groups divided by the mean squares within groups. And you'd have to, this would be the F obtained, and you'd have to compare your F obtained to a critical F, and your critical F, so your F crit, is going to be equal to, you look up the F, and of course we have an alpha level, and I can't do special characters here. Alpha, say like a 0.05, and we're going to use 2 degrees of freedom. So if you look it up, you'll see that there's actually 2 degrees of freedom for the F table, and it's degrees of freedom between, comma, degrees of freedom within. So that's how you do that. It's always between degrees of freedom are listed first before the within group degrees of freedom, even when you're reporting these statistics as well. So those are some basic terms. Next video we'll do an actual example.